Hi everybody, welcome to what week are we in now? Week 2. How many sessions? How long have we got? We've got today, the 19th, the 26th, the 2nd, and what I'll probably do, because the exam is on the 8th, is I'll run a, I don't know, hour or 2 session where you guys can just come in and we can go through anything you're really struggling with. But yeah, so we've got today, which is going to be equilibrium, KC values, all that fun stuff, equilibrium expressions, answering questions based on KC values. And so that'll be today. Next week, we'll do electrochemical cells and galvanic cells. So that's the 19th. The 26th, we can do anything in particular. Organic chemistry, maybe on the 26th. Sounds good. Organic chem on the 26th. The chemical analysis, so infrared spectroscopy, chromatography, all that fun stuff. Gel electrophoresis, we'll do that on the 2nd. And then the exam's on the 8th. So on that weekend, I will likely run a drop-in session where you guys can just come and bug me, come and chat, whatever you want to do. Because we are, what, 4 weeks away from the end. All right. Question 1. I'm going to give you guys a couple of minutes to have a go. Question 1A, and if you get a chance, question 1B. So 2-minute timer. Sorry. So if you get it, throw it in the chat and set a timer, 1 minute. Is everybody excited for the end? Not like death, just the end of year 12.
Yeah.
Wait, death or the end of year 12?
End of year 12.
Okay, cool. Just want to make sure. It's some seriously depressed students after the mock exams at my school. Got 10 seconds. Kai, what's the balanced chemical equation here? Feel free to speak it rather than type in the chat. Not putting you on the spot or anything. I just expect a lot of you.
All right. CO plus H2O, and then the brackets are gas.
Yep.
The G.
Yep, both gases. Very, very important when you're talking about equilibrium to include the state. Why? Anyone know why?
It's worth half a point.
Yes, it's worth half a point, Kai. There's something more important. We don't include gases and liquids and solids when we're doing equilibrium expressions. So if you're asked to write a balanced chemical equation, make sure you put the states. Because as Kai said, you'll lose marks if you don't. But then if it asks you to do an equilibrium expression below, you won't get it right. Sorry, can I continue? We've got CO plus H2O.
Then it goes to CO2 plus H2 plus heat.
Perfect. Is that balanced?
Yes.
All right, so the answer to the question would look, get rid of my biology, it's sacrilege talking about biology and chemistry. So we have CO as a gas plus H2O, and all of this comes from the question itself. We're talking about equilibrium expressions. You'll lose half a mark if you don't put the double arrow. So it's only a 1 mark question, right? But in order to get that full mark, you would need to have it balanced, the correct states, the double arrow equilibrium, and the fact that we get a release of heat. What kind of reaction does it tell us we've got if we've got a release of heat?
Exothermic, right?
Yeah, exothermic. Why is that important in an equilibrium reaction, Russ?
No, sure.
Well, if we're going to manipulate the reaction to go forwards or backwards, we need to know if it's exothermic or endothermic. So that's question. That's part A. Move my fat head so you can see that. So part B. What would happen if we increase the pressure to the equilibrium position and the rate of reaction if this is a closed system? Now this one should be fairly simple. I'm going to give 90 seconds. Let me do this entire session standing because I'm like I sit it down too much. That's how you know you're old. Is when you injure yourself sitting down too much. All right, so what happens to the rate of reaction when we increase the pressure? Or a different way of saying it, what happens when we reduce the volume?
Nothing.
So what does collision theory tell us? So that's the equilibrium position. So if the equilibrium position won't change if we change the pressure, because there's the same number of gas moles on both sides. You've got 1, 2 over here, 2 moles of gas. 2 moles of gas. If we increase the pressure, it doesn't matter what happens, nothing will change. So the equilibrium point will stay the same. So what does collision theory tell us about rate of reaction? The more collisions, the faster the reaction. So if I've got molecules spread out like this, are they going to react very quickly?
No.
No. If I halve the volume and put them all down here, are they more likely to collide with each other?
Yeah.
So in this question, the rate of reaction will go up if we increase the pressure, but the way the reaction goes won't change because there's no benefit. They both have the same number of gas forms. Let's go. So, knowing that it's an exothermic reaction, what would, I'll give you guys again, maybe 90 seconds, what would the effect of lowering the temperature of the reaction vessel be on the direction of the reaction or the equilibrium point? Go 90 seconds again. Feel free to research, feel free to Google it. We have an exothermic reaction, which tells us that every time the reaction goes forward, it's releasing heat. Every time it goes backwards, it's absorbing. So in this box here where our reaction's happening, I've dropped the temperature. Which way is the reaction going to go, forwards or backwards, to counteract the reduction in temperature, to make that warmer? Fan back on me. Anybody else live in North Queensland? Where are they going to be there? There's all the Sunshine Coast in Brisbane. All right. Who wants to have a go at the answer?
I'll favour the forward reaction as it's exothermic.
Yes. So the reaction will favor the forwards direction because every time it goes forward, it's releasing heat to counteract the change, which was lowering the temperature. Okay. Can everybody see question 27? Everybody
Yes.
wish they didn't see question 27? So what does the Ka value tell us of an acid? Well, what's the Ka of an acid? What does it mean?
The concentration.
Yeah, effectively, the concentration is just the negative log of the Ka. So the Ka is the dissociation constant, or how strong or weak the acid is. So we have polyvinyl acetate here. Don't need to know what that is. It has a Ka of 1.8 times 10 to the power of -5, or 0.00018. Very low. It's a very weak acid. So Does everybody remember what dissociation of an acid in water? What happens there? What does the acid lose? Right, I think we found the right question to be studying. Okay, so when an acid dissociates, it loses its H plus. So if methanoic acid, which is CH3COOH, goes into liquid water and loses its H, where does the H go? Where would the H from methanoic acid end up? H3O plus, yeah. So the dissociation reaction that we answered this question is methanoic acid plus water gives us methanoic acid minus a H plus. And remember, if you're taking a H plus off the end, it becomes negatively charged. So that is the chemical equation for the dissociation of any kind of acid, doesn't matter what kind of acid it is, into water. The water becomes acidic, and this guy is now CH3COO minus. And it's balanced. Oh, yes, I know, I didn't write the states. Aqueous. So get full marks, that's what you would need to have. You don't need to write the dissociates or loses thing. So that's the balanced chemical equation for that question. So here we have, again, I'm going to give you guys 60 seconds to have a think about it. So dissociation constant is the same as our equilibrium expressions. Again, timer on 60 seconds to have a think about it. So I don't just want to be giving you the answers. I want you guys to have a think about it first, even if you don't get an answer. So we're looking at effectively the equilibrium expression of that reaction that we just wrote down. So with our acids, we're looking for the Ka. This was an equilibrium expression. We'd be writing Kc. So we have the products over the reactants. What don't we include in an equilibrium expression?
Water.
Yep, water, liquids. So our aqueous solutions we had in our products, we had H3O plus we had CH3, COO minus over, we don't include water. So that is our acid dissociation expression. It is exactly the same as if we were writing the equilibrium expression. Everybody good with that? Same as your equilibrium expression. Okay, I'll just stop sharing so you can see it.
Is there meant to be a H on the end of the CH3COO?
Yes, because that's the product, the reactant. Yes, well picked up. I'll pretend I did that on purpose.
Okay.
So that's our Ka, or our acid dissociation expression. CH3 COOH becomes H0 plus and CH3 COO minus. All right. So how can we calculate the pKa for ethanoic acid? Does anyone remember what the pKa value is?
You don't take log of 1.8 times 10 to the minus 5.
Yeah, the negative log of the acid
Right,
dissociation constant. So to calculate the pKa, as Ross, aka Captain Math Methods, as we call him, we take the negative log of the dissociation constant, which in this case is 1.8 times 10 to the minus 5. Anyone got their calculator handy?
I think it's 4.7447.
Why would we only have the answer in two significant figures at 4.7?
Because it's less awkward.
I mean, that's technically correct, but because in our equation, 1.8 times 10 to the power of minus 5, 1.8 only has two significant figures. So we would only have an answer with two significant figures. So it'd be 4.7. Okay. So everyone has, again, 60 seconds. This is probably the trickiest question. Oh my gosh, it's 8:30, right? The fact that this question's only worth 2 marks is ridiculous. Does anyone have any ideas of how you'd answer this one? So what are we trying to calculate when we're looking at the pH? What does the pH actually mean? What we're actually looking for here is the concentration of H3O plus. I'm actually going to turn my webcam quality back up. Let's turn it down. Someone could keep up my fully sick HD stream. Okay. pH is just the concentration of H3O plus. So in order to go from concentration and Ka to H3O plus, we do use the following equation. Ka equals. So we have H2O plus concentration squared over HA. Write that formula down. What we don't know is this. So I'm kind of Ross, just a terrible person. How could we rearrange this formula to solve for H3O plus? Because we've got Ka, which is 1.8 times 10 to the power of minus 5. We don't have H3O plus squared. HA is the concentration of the acid, so we have 2.4 times 10 to the power of minus 4. Ross, how am I going to solve for H3O plus squared?
You times K by HA, or sorry, the square root of K times HA.
Yes. I'm going to do it
I
slightly.
don't have my calculator on me, so I can't do the actual calculation bit.
Just correct it for everybody. It's okay. So we would rearrange the equation so we had H3O plus equals our Ka, everything in brackets, always in brackets, times by, we don't really need the times by there. We've got brackets, but I'll put there anyway. Then we've got the concentration, which is 2.4. So who remembers their log laws? What do we do here? We don't really need a calculator, a fancy calculator to calculate this. Take 1.8 times by 2.4.
Is the H3O plus still squared though?
Yes, sorry. So that would give us, and I'm going to go back up to the top. Actually, I'll just look down. So do this calculation. You don't need a fancy calculator. 1.8 times 2.4 should give us 4.32 times 10 to the, if we've got multiplication, we simply add to 10 to the minus 9. I need to get rid of the squared. How do I get rid of the squared? Would I have to take the square root of both sides? And you want to fancy calculator, then do square root of 4.32 times 10 to the negative 9.
I think it's 6.57.
0.57 times 10 to the negative 5.
5, yeah.
Perfect. So next step, we take the square root of the sum of the Ka and the concentration. So our H3O plus no longer squared because we've square rooted this answer. Gives us 6.5 per 7 times 10 to the power of negative 5. So, one more step. So we now change the calculation. We add in another formula, which is our pH formula. And this should be in your formula books. So pH equals the pKa. Can somebody check and make sure I'm not telling lies that it's in your formula book? So if we sub in our numbers, and this is what this part of the exam is about. The first paper, you get something nice and easy. You'll be already given the pK and the concentration, and you can calculate the pH comfortably from that. So here we've got pKa, which we calculated as 4.7. Why do we use a logarithmic scale for pH calculations? So we use 6.5 over 2.4 times 10 to the negative 4 as the concentration. Anybody want to do that calculation on the calculator? Should get a negative number for the log calculation. So we should have pH 4.7 plus minus 5.6. So pH will equal 4.14. If you're calculating this for an acid and you get a number above 7, you've made a terrible mistake. How's everybody's brain going after that?
Yeah, all right.
Does it make sense?
Yeah.
Okay, cool. So a lot of the time, you have to do all the hard yards in these questions. And the hard part is not doing the maths, not doing the science, it's figuring out what science and maths do. All right, when you guys are finishing that, it'll be fine. Another question. Might do some stoichiometry as well in the next few days. Because I guarantee everybody's got that. All right, let's have a look at a sorry if you're having to see you or watching. All right, last question for you. Again, part A, I'm going to give you 60 seconds. This is where we'll finish there. Right. Question A, identifying which reactant is oxidized and which is reduced. 60 seconds. I can see it with my eyeballs. You don't need to do maths of this. So what element is oxidized?
The copper, right?
Copper is oxidized. Why?
Because it's lost to.
It's going from Cu, in which it has an oxidation state of 0. So we're going from copper, which has an oxidation state of 0, to copper 2+, and it's losing 2 electrons. So it's oxidized. What was the other one? Ag+? So silver is going from being positively charged, we add an electron, and it becomes neutral. So from +1 to 0. So it has been reduced. So copper atoms, sorry. Does that make sense to everybody? Copper has gone from 0 to +2. It's lost 2 negative charges. Silver has gone from +1 to 0. So it has gained a negative charge. Who remembers? Oil rig.
Yeah.
Oxidation is loss, reduction is gain. All right, next part of the question. So how could I demonstrate this reaction? So this is a tough one, so I'm going to go through this one. So this is a single displacement reaction. What we want to do is have a double displacement reaction. Or even, actually we can do it with a single displacement reaction. So we could take and we can put silver nitrate into a solution. We take silver nitrate, we take copper wire, everyone knows the color of copper, right? It's got that, looks like pennies. What will happen here is you'll have copper we take copper, we add silver nitrate, and we'll get a single displacement reaction. And we'll end up with copper 2 ions in the solution. So the solution will turn blue. That's how we could demonstrate the reaction. We're swapping copper and silver around. Because here, copper is 0. Here, silver is +2. Here, silver is 0. Copper is +2. And you'd be looking for a change of color in the water. Actually, I have color now. This is what copper sulfate looks like. I'll see why I have it. That color. That'd be the color you want. So the next part of the question is, what safety considerations would you need whilst safety, ethical, and environmental considerations would you need to take into account for this? One being, don't pick up copper without gloves on like a moron like I just did. There you go, I gave you one. As with most chemical experiments, don't be an idiot. Wear gloves, don't touch your eyes when you've got stuff on your hands. Don't flush copper down the sink. Don't flush silver down the sink. Copper is a heavy metal that bioaccumulates, so it's not good for the environment. All right, we might have best time for one more question. Let's have a look. One that I would hope everybody knows, and if you don't, then you need to study this ASAP. So 60 seconds, have a think about this one. All right, Kai, what is the balanced equation for production of ammonia?
N2 plus 3H2
Yep.
and then 2NH3.
Okay. Is it exothermic or endothermic? It is exothermic. Why do we need to monitor the conditions? What don't we want to happen to the equilibrium? We don't want the equilibrium to go backwards. It is an exothermic reaction. So if we increase the temperature, the reaction will go backwards to absorb the heat. There are 4 gas moles on this side and only 2 on this side. So if I decrease the temperature, decrease the pressure, the equilibrium is going to go, well, the reaction is going to go backwards to the side that has the most number of gas moles. So when we're producing ammonia, we want to produce as much ammonia as possible. We need to monitor the temperature. We need to monitor the pressure. All right, I think we'll leave it there for today. Next week, we're going to do galvanic cells and electrochemical cells. We did a little bit there, but we'll go into the calculating potential voltage and stuff. So we've got, I think I'll do stoichiometry as well. Everybody want to go over the theoretical yield, percentage yield stuff as well?
Yes.
Yes.
Sweet. So stoichiometry, galvanic and electrochemical cells. I'm thinking as well IR spectroscopy and all the chemical analysis stuff. Probably a lesson on that. And then the last one can be organic chemistry. And I will see you guys next week.
Thank you.
See you
Thanks.
guys.
Cheers.